Well, thank you for joining us here at the Mentored Engineer. Today I'm sitting down with Corey Rasmussen, and we're going to be learning a little bit more about him. So Corey, first question, why did you become an engineer?
Well, Tom, I've always loved tinkering with stuff. From a very young age, I was always taking things apart, and then I get yelled at by my parents, and then I try to put them back together as best I could. So I've always loved that. I've always been known to, test the limits of stuff. And in fact, one time when I was in 8th grade, I decided to build my own roller coaster. And it was very simple. It just had a little lift hill and went down, made a couple turns, and then came back up, and it would stop. And we actually tried it with one of our neighborhood kids, and it didn't end so well, but nobody really got hurt. But always loved doing design work like that and testing out and stuff. So it's no surprise that I became an engineer after that.
Great. So could you tell us a little bit more about your background?
Sure. Well, I got my Bachelor of Science in Mechanical Engineering from Baylor, and ended up staying in town there and worked for a filament winding company, and they would take fiberglass filaments and wind them on steel mandrels, and then process them into insulated fiberglass sections. And it was wonderful because I got to learn all about the manufacturing side of the business, and how everything that is designed needs to be manufactured, and got to see that process throughout. So after that, I worked for a small product development company where I had my mentor for 5 years, and he really showed me everything I know about mechanical engineering, and it was wonderful. I was able to basically come in not being able to calculate anything to leaving, being very confident in that work, and being able to show other people how to do it. They did a lot of aerial lift type equipment, so a lot of it was on mobile trucks and stuff like that. After that, I moved to North Carolina and worked as a aerial lift designer, and until this year, 2018, I worked there. But now I have branched out and started my own engineering design firm.
Great. So with that background, could you tell us a little bit more about the projects that you've worked on?
Sure. Well, as I kind of mentioned, a lot of it had to do with some sort of mobile equipment. So it wasn't buildings or anything like that. It was things that drive around and do a job. So we're talking pressure diggers, we're talking underground line pullers, aerial lift equipment. We even made some antennas for the Navy. There was street sweepers and ground heating equipment. So all sorts of different industries would come to us for designing advice.
Great. So from that, do you have a favorite project or favorite design?
Well, it's always hard to narrow it down to one. So I've got two that I'd like to share. The first one was my first big project where I was the lead engineer on. And it was an underground line puller. And basically what it was an arm that would reach down into a manhole cover and pull electrical and utility cables from one manhole to another. And it was a very difficult project, not so much in what it did, but we only had 19 weeks to go from what was approved as a concept to the final product. And we actually had to build one in that 19 weeks. Now, one of the most difficult parts about it was cylinder design. When you make a custom cylinder, as these were, they take 12 to 16 weeks to quote, buy and order, and then finally get the cylinder. So we had 19 weeks to do something, and a 16-week part of it. So we ended up doing about 2 weeks of designing, and then we purchased the cylinders as quickly as we could, just once we knew about what they were. And we refined them a little bit in the beginning parts, but yeah, not something I would wish upon anybody, but it was just interesting. We designed things around cylinders rather than designing the cylinders around the apparatus. The second thing was on an aerial lift device, and it was a redesign of a weldment that mounted 2 cylinders on a boom. and the weldment we were redesigning had 13 parts in it. 7 of them were bent, and it weighed about 60 pounds. It was a hassle because things had to be welded on, and then more parts added, and then welded again. And it really was a hassle for our shop to handle. They wanted, you know, a whole different sub-weldment for it, and then just add it on in one piece. Well, right as we were redesigning this was about the time that I started looking at joint design and looking at stress flow in a more scientific approach than I had ever done before. And what I wanted to do and was able to do was to eliminate 6 of the parts. So we went from 13 parts to 7 parts. None of those parts were bent. It actually weighed 20 pounds less and could be welded on all at once. So it was just a win-win-win all the way around. It made the shop very happy. It made our bottom line very happy, and the managers happy because of that. So there was a lot that went on there, and it was just, you know, every time I see one of these trucks driving down the road, I just smile because it was, you know, just a win-win-win all the way around. So.
Well, thank you, Corey, for sharing a bit more detail about your story and your background. And we thank you to the viewers who have come and watched another video here. We do invite you, please join the Mentored Engineer for updates and the new resources that will be available so you can have access to those as well. So as always, we thank you for viewing and have a great day.